In this episode of the Sustainability Podcast, let's talk about fleet management, and in particular, the rise of connected vehicles in global supply chains. Fleet Management 2.0 is redefining transportation by integrating IoT sensors into vehicles, thus fundamentally shifting fleet operations. These sensors capture very precise data on factors like location, speed, fuel usage, driver behavior, and many other parameters. And they transform fleet management from being reactive to truly data-driven decision-making in near real time. This visibility enables fleet managers to oversee both individual vehicles and the entire fleet, facilitating immediate adjustments to changing conditions. This IoT data allows managers to detect inefficiencies, predict maintenance needs, and even assess driver performance. For instance, Summit Materials uses the Samsara Connected Operations Cloud across its 4,000 vehicle fleet, centralizing data on fuel usage, emissions, and diagnostics to improve fuel efficiency and advance sustainability goals. This integrated approach enables Summit to reduce idle time and fuel wastage, aligning with its goal of net zero emissions by 2050. Similarly, UPS uses its Orion system, which integrates real-time and historical data to optimize delivery routes, saving fuel and enhancing delivery reliability. Orion has proven essential in reducing travel distances as well as cutting down on greenhouse gas emissions associated with unnecessary mileage. This type of visibility and control is truly redefining fleet operations, creating a framework for companies to enhance efficiency and precision across the board. In our increasingly competitive logistics landscape, these capabilities allow companies to remain agile and cost-effective. So, this connected vehicle technology drives efficiency improvements across route planning, driver safety, maintenance, and fuel management. The real-time route optimization allows fleets to adapt to dynamic conditions, be it traffic or weather, to minimize fuel consumption and delivery delays. UPS leverages their Orion's capabilities for real-time route optimization, which finds the most efficient delivery routes, reducing fuel costs and delivery times. By continuously adjusting these routes based on current near real-time data, Orion enables UPS to streamline delivery operations and maximize route efficiency. This approach to route optimization minimizes delays and helps maintain exacting standards of service reliability. Safety improvements are also achieved by monitoring driver behavior like speed and braking, providing data that enables targeted training to reduce incidents and improve regulatory compliance. Predictive maintenance further optimizes operations by flagging potential issues before they lead to breakdowns, minimizing repair costs and downtime. FedEx has adopted predictive maintenance models to maximize uptime and ensure timely deliveries, demonstrating the efficiency gains connected fleets can deliver. Fuel efficiency, of course, is also improved through detailed monitoring of vehicle use, helping companies like FedEx and others reduce costs and environmental impact. Together, these capabilities show how connected fleet technologies support precise, cost-effective fleet management. Now, what are the operational challenges in managing connected fleets? Connected fleets do introduce challenges that require strategic planning, particularly in data management, integration costs, and cybersecurity. IoT-enabled vehicles generate significant volumes of data. This requires robust storage and processing capabilities to manage the information without overwhelming management teams. Failures to effectively filter, prioritize, and analyze data can lead to analysis paralysis, where data volumes hinder timely decision-making. The initial investment for IoT technology is high, involving costs for hardware, software licensing, and maintenance that must be balanced against potential long-term efficiencies. Implementing connected fleets requires a comprehensive cost-benefit analysis to assess exactly how long-term savings and improved productivity align with these initial upfront expenses. Compatibility with legacy systems adds another layer of complexity, as older data formats and technologies can complicate seamless integration. Sobeys addressed these integration challenges by using Samsara's platform to unify operations across its distribution network, thus enabling it to coordinate activities and achieve the required efficiencies. Additionally, that increased connectivity enabled real-time data transmission, which also raised, unfortunately, cybersecurity risks. Protecting this sensitive data, such as vehicle locations, driver information, and operational metrics, does require rigorous cybersecurity measures. Without adequate protection, connected fleets could become vulnerable to external threats, undermining the benefits that they offer. So what are some solutions for overcoming some of these fleet management challenges? Well, to manage connected fleets effectively, companies need to implement robust technological solutions and carefully consider integration strategies. Advanced data analytics can transform the high volume of data generated by IoT sensors into actionable insights that drive operational improvements. Real-time analytics supports immediate adjustments in route planning and maintenance scheduling, optimizing fleet operations and minimizing costs. The predictive analytics, of course, offers the added benefit of forecasting maintenance needs and planning routes based on historical data, allowing for proactive resource reallocation. Partnerships with specialized technology providers such as Samsara offer organizations the tools and support they need to manage these complexities much more effectively. Summit Materials has successfully used Samsara's integrated platform to improve driver safety, reduce fuel waste, and achieve significant cost savings. Incremental integration is often necessary to avoid disruptions when introducing new systems alongside existing legacy infrastructure. Cybersecurity, as we mentioned, must be a priority, involving multi-layered protections such as data encryption, continuous monitoring, and controlled access. This layered approach safeguards sensitive fleet and operational data from potential threats. And with all these measures in place, organizations can then realize the full potential of connected fleet technology by enhancing operational efficiency and data security. So the future of fleet management is likely to include autonomous technology and AI-driven insights that reduce human intervention and increase operational precision. Autonomous systems are designed to reduce the risks of human error, improving both safety and reliability in fleet operations. Amazon Logistics and UPS already use advanced route optimization tools, enabling their fleets to adjust routes in real time to changing conditions, which maximizes route efficiency and reliability. Predictive maintenance will remain a critical tool, flagging potential issues early and minimizing downtime. Autonomous vehicles, as they arrive on the market, will also facilitate greater integration across the supply chain, improving real-time communication and collaboration between suppliers, carriers, and dispatchers. This will result in a much more resilient supply chain, equipped to handle disruptions with minimal impact on delivery schedules. Globally, fleets will increasingly rely on AI-driven scenario planning to anticipate disruptions and develop quick response strategies. These adaptive technologies provide the agility needed to address evolving challenges in logistics. And such a proactive approach will make fleets more adaptable and dependable, meeting the demands of today's and tomorrow's global supply chain. This focus on autonomous, connected fleets signifies a shift towards a logistics infrastructure that is highly responsive and resilient. So what are some recommendations? A phased strategic adoption of connected vehicle technology is essential to balance operational stability with long-term gains. For organizations adopting these technologies, prioritizing high-impact areas such as fuel efficiency and predictive maintenance can deliver immediate returns and help demonstrate the value of connected fleets. So as we mentioned, Sobeys has seen success by initially focusing on fuel management and predictive maintenance, which allowed it to quickly achieve cost savings and improve fleet performance. Investing in workforce training is also critical. Fleet managers equipped to interpret and act on IoT data insights make informed, better, data-driven decisions. Summit Materials has leveraged this exact approach using Samsara's platform to monitor safety and fuel efficiency, directly supporting their operational objectives. And as we introduced, cybersecurity must be a top priority in this process, with comprehensive protections in place to prevent data breaches and secure sensitive information. Companies should choose platforms that are scalable and compatible with existing systems to reduce risks during adoption and during the full rollout. The incremental approach allows businesses to test, measure, and refine their strategies before the full rollout, ensuring that innovative technologies align with overall organizational goals. So by carefully managing each stage, companies can make the most of connected vehicle technology without disrupting daily current operations. This structured approach supports both immediate efficiency gains in the pilot phases and long-term improvements in fleet management over the longer and larger rollout. So summing up, connected vehicle technology is reshaping fleet management by increasing efficiency, safety in the logistics sector. Companies such as UPS, FedEx, Amazon Logistics, Summit Materials, and Sobeys demonstrate that centralized, data-driven fleet management drives down costs, enhances safety, and strengthens service quality. Implementing these technologies involves overcoming integration and data management challenges, yet the potential for optimized routing, predictive maintenance, and better driver management provides substantial returns on investment. Careful, phased adoption of connected vehicle technology allows companies to leverage these benefits without interrupting day-to-day operations. Training and cybersecurity must be integral to any implementation strategy to ensure data protection and effective use of the analytical tools themselves. This approach allows organizations to build smarter, more responsive fleets that are better equipped for today's global logistics demands. As businesses continue to integrate connected vehicle technology, they'll be creating supply chains that are truly more agile and resilient. These connected fleets are no longer a future concept, but truly are a present-day operational tool, enhancing the competitiveness and reliability of today's logistics networks. Companies that embrace these technologies stand to gain a significant edge in an increasingly complex global market. Through this transformation, connected fleets will play a key role in meeting the evolving needs of modern supply chains today and tomorrow. Thank you again for joining us on this episode of the Sustainability Podcast. We look forward to seeing you on an additional episode very soon.